Hi, everyone. Welcome to reInvent. I'm Mark Powell. I'm a Principal Product Marketing Manager here at AWS, and I focus on the compute space. Joining me today is Peter. Peter, why don't you introduce yourself?
Hi, I'm Peter McKiernan. I am a Senior Product Marketing Manager in EC2 Networking.
And today, Peter and I have the privilege to join all of you at reInvent to talk about a couple of our favorite launches and announcements that have happened over the last couple days so far. So thanks for joining us and come along for the ride. So Peter, I started, so I get to go first with my first choice, if that's okay with you.
Go for it.
All right. So one of the things I've had the distinct pleasure to be a part of at AWS has been our work in our silicon innovation space. And one of those pieces has been Graviton. And so far, since Amazon introduced Graviton, which is an x64 based ARM architecture, we started that, and we now have introduced. This is our announcement for our 4th generation part. And since the first discussion of Graviton happened in 2018, Peter, here we are, 5 years later, and already introducing that 4th generation, which is pretty incredible when you think about it as well. So I've got a picture here of Graviton on the left-hand side. Although the picture is stunning, Peter, that's not entirely the beauty of it. Is one of the first things we want to talk about is some of the security that we have developed for the Graviton 4 part, because I know that all customers out there likely are concerned and care about security. So we've developed encryption support on all interfaces so that communication with everything from DRAM to our Nitro cards, which are already fully secure environment off of our Nitro system, and our coherent link are all encrypted, so that there is so that we reduce the threat vector here as an attack. So that's item number one, which I think we devoted an entire slide to, but I think it's super important to talk about that security element that's here. The next thing that we're doing here is these are our custom processors, as I said before, from Annapurna Labs. And we are going to deliver 50% more cores, twice the cache, and 75% more memory bandwidth, which these numbers, I think, when you consider, if we were here talking about at reInvent when Graviton 3 was here, Graviton 3 had numbers, 40% better than Graviton 2, and 60% more efficiency in the sustainability space. And then here we go off and we've got 50% more cores, twice the cache, and 75% more memory bandwidth. I still kind of in awe of these numbers here, Peter.
That is a huge increase.
Yeah. And the other thing, that's not all, is that, these are available. If anybody is interested in trying them out, you can take a look at the R8G instances. They are available in preview right now. So you can apply to be a part of the preview. And for those who don't know, remember the R instances are our memory optimized instances. And so Graviton 4 is the first member of our 8th generation instance family here. So R8G for Graviton here. So pretty cool that they're ready, available for everybody to take a look at. It's not just as they say, Peter, it's not just a pretty picture here.
That's awesome.
Yeah. All right. So your turn to talk a little bit about a networking-based feature that's out there.
Yes. So this is one of my favorite features that we've talked about. And basically it has to do with AI. Shocking, right? Someone talking about AI at reInvent.
Okay.
Well, there's really 2 parts to AI as we think about it. There's the AI we're using to help make all your AWS console and everything else easier to use. But then there's also the tools that we're giving you to give you these amazingly high performance compute clusters to actually run your models and train your models and things along those lines. And to get the speed increases that we're seeing, you really have to optimize every single part of that cluster. And one thing that sometimes gets overlooked is where you're running different jobs. So anytime you make a cluster bigger, latency is a function of physics, right?
That's right.
So how do you do that while still decreasing latency? Well, one thing we can do is the topology API. And so here's the challenge. Let's say you have a job and it's running on in 3 different places in the network. That means you can have up to 3 hops between different instances that are talking to each other a lot. What the topology API lets you do is move all those jobs into the instances that are all in the same part of the network. So now your latency drops, your performance increases, and you have much more efficient use of your overall cluster. So I think this is really cool. It's certainly not the only thing we're doing in terms of networking for our AI ML clusters, but this just is, I think, a great example of how we're looking at every single part of that overall challenge and making sure we're delivering everything you need to run in the cloud.
Yeah, and the thing I like about this, Peter, is that you use that word efficiency, and we were talking earlier about the efficiency associated with the design of the Graviton architecture and how customers that are looking for and have sustainability goals could benefit from using the efficiency of that. Part of this is also efficiency shows up in a number of different ways in performance. Here, efficient design of that network topology here is really important. And you talked at the beginning of this how latency as well. All of these go to performance here. So I think this is another great example. Both of these first 2 features have a lot of performance aspects to them that I think our customers out there are going to really benefit from. So good choice, I would say. All right. So back to me. I'm going to talk a little bit about, keeping in the AI ML vein over here. I'm going to talk a little bit about Trainium 2. This is our new training chip. So there's a lot of discussion about training and inferentia. And so there's 2 elements of machine learning. I think many of us know this is that train, and you train lots of different parameters and then infer from that training that you had done. So our second Trainium 2 here is our second generation here. It's actually 4 times faster than Trainium was. And you can now have 20 exaflops of on-demand supercomputing performance, which, the numbers for Graviton to me are huge, especially since somebody who used to work extensively on the CPU side of the world. But these, dealing with exaflop scale of stuff is really, I don't know, Peter, about you, but still for me, anything above 1 billion, it starts to be like challenging for my mind to completely comprehend exactly, the scale that we're operating here. But customers here are looking at, hundreds of billions of parameters that have to be here and going into this exaflop scale here. And finally, you're going to be able to do out of the box, kind of seamless integration with major prototypes out there, such as PyTorch, TensorFlow, and JAX, which I think is a really cool thing. So Trainium 2 is on the hook. It's coming soon here. And I just think it's a really great thing to hear about. And it's as more parameters are involved as we go from millions to billions and if not more trillions here, I think Trainium kind of positions folks to take a look at that going forward. Cool. All right, maybe I can do one more here, Peter, before I let you take one more as well. I want to talk about the kind of sister-ish product or brother product to Trainium, Inferentia. Right, so we had our Trainium 2 instances. I just wanted to mention our Inferentia 2 instances as well. So with these, this is where you are doing the inference off of those models. So that's why I wanted to pair them together here for a brief second. So Inferentia 2 delivers, 480 gigabytes of high-speed accelerator memory. And I think in the last example, Peter, that you gave on the networking side, we're trying to combine things into singular nodes to reduce the latency. So this is, this is that high-speed memory to reduce that, and 4x throughput and up to 10x lower latency than the previous Inf1 instances. So the performance here, just on so many levels, each of these are not quite performance numbers, but they all impact that performance. Is what I like about it. And now it's optimized to deploy 100 billion plus parameter models at scale. So I think this is another example of some innovations that have come from AWS in this AI space.
And it's more energy efficient.
Indeed, indeed. Actually, I believe, if I'm not mistaken, Inferentia 2 is our most energy efficient, one of our most energy efficient processors that are out there. So, Peter, I think it's time to give the floor back to you so you can discuss one or two other networking features that we have coming.
All right. Well, the first one is something that is near and dear to my heart, and it is called AWS Cloud WAN Tunnelless Connect. Now, if you're familiar with Cloud WAN, it is a way for you to build a global network backbone for transit using an AWS service, and it allows you to do to connect your locations together all over the world. And one of the ways that is very popular to build an on-premises WAN is to use SD-WAN devices, right? Software-defined WAN devices have been around for a long time. They're super popular. And in the past, when you wanted to connect your Cloud WAN network to your SD-WAN network, you needed to use a GRE tunnel between your SD-WAN head and inside of AWS. And that meant you were limited to a maximum of 20 gigabytes per second. You could have 4 tunnels, each at 5 gigabits per second. And so now you can have a maximum of 20 gigabits per second. We are getting rid of that GRE tunnel. And so you no longer are limited to that 20 gigabit per second, but you can go all the way to the AZ limit, which is 100 gigabit per second. So you have a 5 times increase in speed. And
Wow.
We worked with Cisco a lot on this, but we've worked with a bunch of other AWS partners that are doing a great job in supporting this within their products.
That's pretty incredible. Now to get almost AZ level networking bandwidth that's pretty cool. Hey, I think we have time for one more feature here that I want to cover, and I think it's similar but a little bit different. A lot of customers out there there's been a surge in people using GPUs, Peter, that are out there, and we announced this is quite a little bit before reInvent, but I think it's super important to customers. One of the things we announced was Amazon EC2 capacity blocks.
Mm-hmm.
And what are capacity blocks? This allows customers to reserve capacity for, in this case, it's the P5 instances. But the idea is that if you're going to use a GPU, Peter, you can schedule it in advance. You can book for up to a week or several weeks at a time, but it gives you an idea on how to schedule so that that you're going to have the GPU resources there when you need it. So there is no question any longer, or will not be, when you use this feature, on whether you're going to have access to it. And a lot of times our GPU customers tell us that many of their activities are very schedulable, that you're doing something and you're going to need the capacity in 2 or 3 weeks or something like that. And so this gives you a great way to actually take a look at it and do that here as well. So you can reserve it, and there's a lot of parameters that you can put here. You can specify the size and the date and the duration. And these are co-located in EC2 Ultra clusters. So you have reliable access to GPUs. I think this takes away some uncertainty that customers may have about using or leveraging the GPUs. And it ensures that we pair our capacity with customers that need it. So I think another great feature for customers here to take a look at. So I think that this is a brief summary of some of the things that are out there that we have. There are a lot of sessions from the networking side and the compute side that I encourage everybody to take a look at this week at reInvent. And it's been my pleasure to join Peter here. It's been my pleasure to be able to talk to all of you about some of those features. And thank you, Peter, for joining me today.
My pleasure. We'll see everybody at reInvent.
Absolutely. Bye.